Hello everyone. Today we're going to learn the last section in chapter 2, which is the inverse of a square matrix. So firstly, I'm going to let you know what's the goal for this class. Actually we want to solve a linear system, ax equals b, okay? And we are going to learn inverse matrix, and it's look like this. So look like this. It's kind of it's like a 2 times 1/2, which is 1, right? So we have inverse matrix, which is inverse times A, which is similar to 1, but is identity matrix. And let's take a look. So we use this times the both sides of this equation and equals A inverse times B. So look at this one. So because this inverse is defined to be I times X is X itself. So it equals this one. So the goal for this class, we want to study how to find the inverse matrix and times B, and we can find the solution for the X. Okay, so let's take a look at definition for the inverse matrix. Definition 1. Firstly, A has to be a square matrix. I will let you know why. Okay. If there exists another n by n, same thing, n by n matrix, and the notation is like this. Okay, A and to the -1 power, but it means inverse, satisfying A times A inverse equals A inverse times A, which is In. Okay, then we call this is inverse to A. This matrix. Okay, this is the definition. It has to be n by n because it need to multiply A by 2 sides on both sides, so that's why it has to be like a n by n. And the matrices that are not invertible are called singular. So that's just a definition for inverse and then not invertible matrix. Okay, and now let's take a look at the example. Let's see what's the meaning of inverse matrix. Here be careful, the inverse doesn't equal to 1 over A. We don't do this. For the matrix, we don't have division. Okay, so let's see, if A equals this one, 1, -1, 2, 2, -3, 3, 1, -1, 1, verify that another is inverse, that B 0, -1, 3 is the inverse of A. Let's take a look. You can see here the matrix A and B are totally different, right? So it's we couldn't see any connection between them. But if we want to verify their inverse to each other, so we can do the multiplication. So let's see, A times B equals what? Okay, A equals A times B. So we just multiply them together. Actually, when we multiply them together, we can try the first row and the first column. So it's going to be 1 times 0 minus 1. Let's see. And plus 2. So it should be -1 plus 2, which is 1. And you can check how about the next number. So this should be the first row, second column, right? A times B. So first row, 1 times 91. 91 times 91, 1, so 0. And 2 times 0 will be 0. So second number is going to be 0. And then you can just do the multiplication, and we will get actually this matrix. This is the identity matrix, right? Which is I3. Okay, and the other way, we can try B times A. We can also get 1 0 0 0 1 0. Okay, even they look totally different, but when we multiply them together, it's going to be identity matrix. So actually B is the inverse of A. We can write down this way. Now we can try this exercise problem. 4 9 3 7 A and the B equals 7 negative 9 negative 3 4. Let's take a look. I'm going to give you a solution here directly. So A B equals 4 9 equals should be 2 by 2. 4 times 8 27 28 minus 27 1 negative 36 plus 36 0 21 minus 21 0 there should be 1. So same thing, BA is let's just try. Okay, diagonal, so going to be 1. I'm going to try A to 2, second row, second column, 1. So in this case, they are inverse to each other. Now let's take a look at a theorem. Theorem 1. So this means if the inverse matrix exists, okay, matrix A like is invertible, the inverse matrix exists, then the linear system, which is AX equals B, has the unique solution. And what's the solution? Solution is X equals A inverse times B. Okay. So this is the solution. So the proof is like at the beginning. If we have this one, we multiply inverse on the both side, at both sides. Okay. And if you times from the left, for the right side of the equation, we also need to times from the left side, because for the multiplication of two matrices, we cannot change the order, right? So if we both times inverse from the left side, and those kind of like a I times X, and I is identity matrix times anything just equals that matrix. So that's why. Let's see. Definition 2. Next, we are going to learn how to find the inverse matrix, because we can use this way, we can use this formula to solve the solution. So we need to know how to find the inverse matrix here, right? So let's see. The method of finding the inverse matrix is called Gauss-Jordan technique. Definition 2. Of finding inverse matrix is called Gauss-Jordan technique. Let's take a look. I'm going to show you how to find the inverse matrix. So we're going to do this way. Let's see. We put matrix A on the left side and put an identity matrix. Let's see. If A is 3 by 3, we put 3 by 3 identity matrix. Okay, and then we do elementary row operation. This means elementary row operations. We learned this in 2.4, right? And for the left side, we reduce the left side into reduce the row echelon. So, for example, reduce the row echelon will be this form. So, make A into identity, then the right side will just become the inverse matrix. Okay, if we write this in an easy way, so it should be like we have I and reduce this into A inverse. So this is how we find inverse matrix. And here, if we cannot get I on the left side, then this matrix has no inverse. Okay, if S has inverse, the left side can be reduced into I matrix, identity matrix. Now let's take a look how to find inverse matrix. So let's take a look. Example 2. Find the inverse matrix if A is given. So we start from the easy one, which is 2 by 2, 1, 2, 1, 3. Okay, let's see. Find the inverse of this matrix. So same as we said, Gauss-Jordan technique, we put I on the left side, 1, 2, 1, 3, put identity at the right side, 1, 0, 0, 1, like this. Okay, and do the row operation. Reduce the left side into identity. So in definitely first step, we need to make the test into 0, right? So 1, 2, 1, 0. So 1 times -1 at there. 1 times -1. So it should be -1, 1. First step. Next step, left side need to be identity matrix. That means this number 2 position need to be 0. So how to make that into 0? Same as before, Gaussian-Jordan elimination. Alright, so let's see. 1 make that into 2, into 0, so second row doesn't change now. And use the second row times -2, add to row 1. So 1, 0, 91 times -2, positive 2 at there is 3, and 1 times -2 at there, -2. So let's take a look at the right side here. This is going to be the left side is already the identity, right? And so the inverse matrix is just the right side. 3, -2, -1, 1. Okay. And then here, if you have time, we always like to double check our solution. So A inverse times A, which is 3, -2, -1, 1, times A, let's take a look, 1, 2, 1, 3. Is this going to be identity? So 3 minus 2 is 1, 6 minus 6, 0, -1, 0, and -2 as 3, 1. And you can also check, but usually if the multiplication is identity, that means it's inverse. It's correct. Okay, so this is how we find the inverse matrix. Now we can try to do one exercise problem. Here is the matrix A. Let's find inverse matrix. Okay, and the second problem, I give you a 3 by 3. Please try to do this, okay, by yourself. And here I can give the solution. The inverse for matrix for this one is the inverse matrix for that one is -2, -3, 1. I can do the first one for you. So let's see. I'm going to put 2, 91, 1, 0, 0, 1, 3, 91. And we need to create a leading one on the top, right? So we use the row 1 times 91 add to row 2. And then switch the order. So, okay, let's do this right now. Create leading 1 times 91, 1, and then switch the order of each one, row 1, row 2, 2, 91, 1, 0, and make that into 0. So times 92, and this number doesn't change. Times 92 become positive 2, 3, and 92 here. And the row 2 need to times 91, right? 1, 0, 91, 1, 0, 1, 93, 2. So the inverse matrix is this one, exactly same as our answer. 3 by 3, same thing. We just need to reduce the left side into identity matrix. Let's take a look at example 3. We're going to solve the linear system using inverse matrix. And this is going to be in the midterm, first midterm. Example 3. Use inverse matrix to find the solution. Solve the system. Now let's take a look at this linear system. It has 3 unknowns. And firstly, we know what is matrix A, right? And we know what is B. But in the future, you can skip those two, writing down those two matrices. Okay. So here's the B, and what is A? 91, 1, 1, 2, 91, 93, 92, 3, 2. Okay. And right now, we are going to use the method, inverse matrix method. So that means we are going to find the solution by using this way. So first step, we need to find the inverse matrix. How to find the inverse matrix? 91, 1, 1, 2, 91, 93. Gauss-Jordan technique. 1, 0, 0, 0, 1, 0, 0, 0, 1. Reduce the left side into identity. So it's going to be, we need a leading 1 here. So 1. And make the second row into 0 and the third row into 0, right? So 1 time. So I'm going to, there's so many ways to do the row operation. You can do any method you like. There's no unique way. So you can choose whatever like. Here I want to save some steps, so I start from here. I can use the row 1 times 2, add to row 2, make it 0, and then change my row 1. So same thing. 91 times 2, so 2, 0. Times 2, 2 minus 1, 1, times 2, 91, times 2, here, 0. And next, so here I can change that into 0. 91 times -2 is positive 2, so times 92 here. Times 92 is into 0, 1, 92, 0, 92, 0, 1. Okay, and next I'm going to use this one to make those into zeros. Let's take a look. 0, 1, 91, 2, 1, 0, 1. So just row 2 add row 1. Okay, 0 there. 92 and 1, 1, 0. And then times 91 add to row 3. Times 91 times 91, so 94 times 91 1. Okay, and then we can use this number to make them into 0, right? Let's see, we are almost there. Row 3, copy. I'm going to do row 2. So 0, 1, 0, just add them together, -2, 0, 1. And row 3 times positive 2 times positive 2 times 2, -8, so -7, -2 add there, -1. Okay, so this is the inverse matrix. So what's the inverse matrix? Inverse matrix is -7, -1, 2, -2, 0, 1, -4, -1, 1. Just some row operations. Reduce left side into identity. Right side is going to be our inverse matrix. Then what is the solution? Solution equals the inverse times b. So here equals this one, -7, 0, 1 times, let me write down 0 under here. So -4, -1, 1 times b. What is b? Okay, at the beginning we know 4, -7, 10. Just do the product, okay? Let's see what the solution is going to be. So row 1 times row 2, so -48 plus 7, -21. -21 plus 20, so should be 91. Is that right? Second number, second row, -8 plus 10 should be 2. The last number, -16 plus 7 plus 10. So this number should be -6 plus 7 should be 1. Is that right? Yeah, that's the solution. So here is how we find our solution. Okay. Let's see. Here I can give you one exercise, easy one, and you can try by yourself. This here is 2 by 2. Solve this linear system using inverse matrix. Okay, like this one. Now we have a property of the inverse matrix, so we can just do this pretty quick. Theorem 2, some properties of inverse matrix. Okay, so here let's see. We have two matrices, A and B, both be invertible matrix. Then first, A inverse is also invertible. Inverse matrix, inverse equals itself. Okay, so it's like inverse twice become to itself. And A times B is also invertible. And A times B inverse equals B inverse times A inverse. 3. Transpose is also invertible. And transpose invertible equals inverse matrix transpose. Here's just some identity. I think occasionally in the future we may use the second one, and the first one is easy to understand. So those are the properties. Okay, we skip the proof. Skip proof. So that's all we need to know for this section. Let's have a summary. The most important thing is, we need to know how to find inverse matrix by using Gauss-Jordan technique. That means AI reduce this into IA inverse. Okay, this is how we find the inverse matrix, right? Second, solve linear system AX equals B by using the inverse matrix. That means the solution equals inverse matrix times B. So given the system, we know A and find the inverse of A, and then do the multiplication, multiple with B, and give us the solution. That's the only thing we need to know. Okay, we can stop.